Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 CBCS ऑनलाइन क्लासेस रो वीडियोज गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोज गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोज रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू पढे मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई की रखिथिबी तमे सर्च करि परिबो ओके थैंक यू
हेलो स्टूडेंट्स आज टॉपिक रे हमें पी टाइप एंड एन टाइप सेमीकंडक्टर विषय रे पढ़िबा ऑलरेडी तमे एटा प्लस 2 रु भी पढ़िचो तापरे इलेक्ट्रॉनिक्स रे भी तमरो बेसिक इलेक्ट्रॉनिक्स रे या विषय रे तमे पढ़िचो सो गोटे सेमीकंडक्टर को फर्स्ट ऑफ ऑल हमें जदी क्लासिफाई करबा दुई प्रकार अछि गोटे हला इंट्रिंसिक आ गोटे हला एक्सट्रिंसिक सो a pure semiconductor in which there is no impurity, okay, there is no addition of impurity, ताको हमें कहबा intrinsic semiconductor. Okay, now conductivity in case of this intrinsic or pure semiconductor depends upon the number of electrons which are excited from the valence to conduction band. Now the semiconductors can be in the form of elements on their compounds. Suppose example of elemental semiconductors are like germanium, silicon, whereas inorganic compounds jodi dekhiba these are like CDS, GAAS, then GAP, CDSE, INP. Okay, cadmium ro, then gallium ro, phosphorus ro, indium ro, phosphorus ro ei sabu ro compounds, inorganic compounds rohuchi, okay, which are some of the examples. Okay, तापरे total current capital I in case of a semiconductor will be the sum of the currents flowing due to the electron and holes. So total current I will be equal to IE plus IH. So here a point to remember that all the semiconductors have crystalline structure. Okay, acha एबे लिमिटेशन जदि देखिबा इंट्रिंसिक सेमीकंडक्टर रो ताले फर्स्ट पॉइंट रे एठी कहूची in an intrinsic semiconductor the number of intrinsic charge carriers at room temperature is very small, that is nearly about 10 to the power 16 per meter cube. Again a point to remember, GE माने germanium is obtained from ash of coals, okay, कोयला रो जो क्षाररू ash रू and from flue dust of zinc smelters. Okay, तापरे second point limitation रो the breakage of covalent bonds due to thermal motion is the only cause of production of intrinsic charge carriers. Therefore it is difficult to control their number in case of intrinsic semiconductor. Okay, यार number को control करिबाटा टिके difficult हे जाय. तापरे थर्ड पॉइंट रे कहूची the number of electrons are equal to the number of holes. जते संख्यक इलेक्ट्रॉन सेतिकी संख्यक होल रहिबो. Hence we cannot have large number of only electrons or only holes in case of intrinsic semiconductors. तापरे आसीबा एबे extrinsic semiconductor को, which is actually obtained by means of doping. Okay, semiconductor जोटा कि doped हेतिबो with some suitable impurity या सहित हमें मिक्स करिबा. ओके, सो हमें पाइबा गोटे एक्सट्रिंसिक सेमीकंडक्टर. मन रख इंट्रिंसिक सहित हमें सुइटेबल इंप्योरिटी को डोपिंग बा मिक्स करिले एक्सट्रिंसिक सेमीकंडक्टर पाइबा. एंड दीज आर अगेन टू टाइप्स, गोटे हला एन टाइप आ गोटे हला पी टाइप. अ पॉइंट हियर टू रिमेंबर, silicon is found in most of the common rocks. Then sand is silicon dioxide, that is SiO2, from which silicon is extracted. Okay, so first देखिबा एबे n type semiconductor. n type semiconductor पाइबा केमती जदि गोटे हमें pentavalent impurity माने जहार आउटर मोस्ट सेल रे पांचटा इलेक्ट्रॉन रहउथबो, pentavalent impurity atoms such as arsenic, antimony, phosphorus, bismuth etc. याकू हमें नहीं कि डोपिंग करिबा with an intrinsic, that is your pure semiconductor, তাহলে ଆମେ ଗୋଟେ n type semiconductor ପାଇବା। ଓକେ, ସୋ ଏଠି କେମିତି ହେବ ଦେଖ, ସେଇ ଯୋଉ ପାଞ୍ଚଟା ଇଲେକ୍ଟ୍ରନରୁ 4 numbers of electrons will be available and they will make bonding, covalent bond formation କରିବ। ଆଉ ଯୋଉ fifth electron ଟା ରହିଲା, it will be free, okay, from each impurity atom is almost free for conduction purpose। okay, you can also see this in the figure, right? ଏଠି ଦେଖ silicon 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 ସବୁଆଡ଼େ ଅଛି, ମଝିରେ ଆମେ ଗୋଟେ pentavalent impurity atom ନେଇଛୁ, that is of arsenic। so ଏଠି 5 number electron ଟା ଏଇଟା ରହିଲା, which is a free electron, right? so ଏଇଟା ଯୋଉ free ରହୁଛି ମାନେ ଏଇଟା conduction ପାଇଁ available ହଉଛି। so ଆମେ easily semiconductor conductivity को बढ़े पारुଛୁ। okay, so when a fifth group element substitute the sites of silicon ହେଇପାରେ କିମ୍ବା germanium ବି ହେଇପାରେ, then the pentavalent dopant donates one extra electron for conduction and hence it is called as donor impurity। ଯେହେତୁ ଗୋଟେ electron donate କରିଦିଏ ତେଣୁ donor ବୋଲିକି ଆମେ କହିବା। and the total number of conduction electron ୟାକୁ ଯଦି କହିଲା ଆମେ Ne, it is due to the contribution of donors as well as thermally generated carriers। okay, but the number of holes ଯଦି ହେଇଗଲା NH are only due to the thermal process। okay, so in this type of semiconductor, since the majority charge carriers are negatively charged, that is your electrons, so ୟାକୁ ଆମେ n type semiconductor, n for negative। କିନ୍ତୁ ମନେ ରଖ very important thing, n type semiconductor charge କେତେ କହିଲେ ଆମେ ସାଧାରଣତଃ ପିଲାମାନେ ଭୁଲରେ ନେଗେଟିଭ ବୋଲିକି କହନ୍ତି, which is absolutely wrong। n type semiconductor हो कि p type semiconductor हो, तार electric charge ହେଲା absolutely zero, that means it is neutrally charged। okay, अच्छा आगे बढ़िबा। so there is a very little attraction between the fifth free electron जोटा रहुची and the core of the impurity atom, and very small part of energy which is very much less, around 0.045 electron volt is required to make the electron move from valence to conduction band। so thermal energy যদি ଆମେ ଦଉଛୁ at room temperature, it is also enough to make the fifth electron free for conduction purpose। okay, so if fifth group impurity atoms को ଆମେ କହିଲା donor atoms, କାହିଁକି because ସେମାନେ electron donate କରି ଦଉଛନ୍ତି for conduction purpose। and when these fifth group impurity atoms are added to the intrinsic semiconductor, then the energy possessed by the free electrons due to impurity atoms is slightly less than the energy of free electrons in the lowest energy level of the conduction band। okay, so these electrons create a lower energy level just below 0.01 to 0.05 electron volt। okay, so just below the conduction level ये गुटे आ गुटे नुआ lower energy level create करिवो। okay, so this one is shown in the figure। देखो एटा हला तमरो valence band टा, एटा हला conduction band, just ए जो dotted line टा देखुछो एटा होची donor energy level, okay, which is shown in the figure। now since the energy gap reduces due to the creation of donor energy level, so electrons can easily go to the conduction band even at room temperature ଆମେ ଯେମିତି ଦେଖିଲା। thus conductivity in case of n type semiconductors increases very rapidly। okay, अच्छा ये ହେଲା n type। ଏବେ ଦେଖିବା p type semiconductor। so ଏଠି ବି ସେଇ ଭଳିଆ ଆମେ doping କରିବା। now we will dope a trivalent impurity atom like your boron, aluminum, gallium, indium etc, so that ଆମେ ଏବେ p type semiconductor पाइबा। okay, so trivalent impurity माने outermost cell रे तीनटा इलेक्ट्रॉन रहिथबो। okay, so सेही भलिया एटम को आमे जदी ऐड करिबा बा डोपिंग करिबा ताले कोन हबो देखो, trivalent impurity atom will form only 3 covalent bonds जेहेतु तीनटा इलेक्ट्रॉन अछि with the neighboring semiconductor atoms। now one covalent bond remains incomplete due to deficiency of electron। okay, this one is shown here in the figure। देख ये सिलिकॉन 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 सब बड़े अच्छी मझे आम ट्राइवेलेंट इम्प्यूरिटी एटम नौ विच इज इंडियम जार 3टा इलेक्ट्रॉन अच्छी सो एठी बॉन्डिंग करदेला एठी बॉन्डिंग होगला एठी बॉन्डिंग होगला यही बॉन्डिंगटा इनकम्प्लीट रहिला ओके सो टू फिल दिस गैप ये जब या कंप्लीट करिवार अछि टू फिल दिस गैप जाकू कि आमे कहबा होल okay another covalent bond in the neighborhood will be broken and in this way holes will be created which are the majority charge or current carriers in case of the p-type semiconductor remember hole माने आमे बुझिबा जो suppose एटा valence band अछि एठी conduction band अछि electron valence band to conduction band को गले एठी जो vacant space को छाड़ी दिए okay so say vacant space को आमे कहबा hole which has the same characteristics as that of the electron only difference है hole रो charge होची positive okay same charge रहिबो electron रो जेमती किंतु positive रहिबो okay electron रो हला negative charge hole रो हला positive charge okay so এই বলে আমি দেখিলা যে গোটে p type semiconductor रे hole are the current charge carriers okay and here they carry the positive charge okay these holes which move now freely এটা এবে এথিরে এবে হোল ফ্রিলি মুভ করিব ইন দ্য ক্রিস্টাল ল্যাটিস and they cause the conductivity so trivalent impurity atoms will be called as acceptors kaiki acceptors because they accept electrons from the neighborhood bonds okay so এই जो p type semiconductor रे here the holes create an acceptor energy level ଯେମିତି ଆମେ ଦେଖୁଥିଲା ଉପରେ free electron ଗୋଟେ donor energy level create କରୁଥିଲା ଏଠି ଏବେ hole create କରୁଛି ଗୋଟେ acceptor energy level just above the top of the valence band okay so এটা আসছে ଆମର जो valence band টা এই dotted line টা ଦେଖଉଛି এটা this is the acceptor energy level and this is our conduction band so at room temperature the electrons get sufficient thermal energy and can jump easily from the valence to acceptor energy level এই जो छोटो gap टाको easily electron पार कर नबो okay so they create further holes in the valence band as shown in the figure okay एबे जदि देखिबा हमें density of electrons in the conduction band of n-type semiconductor okay याको एबे टिके जदि हमें कैलकुलेट करिबा density of electrons को ताले n type होची हमें जेमति देखिला it is an extrinsic semiconductor so we know that the number of electrons per unit volume okay concentration जोटा in the conduction band it is given by suppose Ne which is equal to n effective into exponential of EF minus EC by KBT okay so एटी हमरो EF हेगला एटा फर्मी लेवल टा then EC होची तमरो energy corresponding to the bottom of the conduction band okay KB हेगला Boltzmann constant T हेगला absolute temperature now N effective this is the total number of effective electrons in the band okay so यार value टा हेला this much okay এটা already हमें Brillouin Jones band theory रे देखिछु now EF जेमति कहली energy corresponding to the Fermi level okay so also we know that the number of vacant states per unit volume in the donor level vacant states जोटा यार value टा रहउची equal to that is nd into exponential ed minus ef by kbt okay ed माने एठी होची donor level रो energy टा so compare जदि करिबा equation 1 आउ equation 2 को देखो ए इक्वेशन और ए इक्वेशन को कंपेयर जदि करिबा आउ इक्वेट करिबा ताले we will get the ratio of nd with n effective so that exponential को एबे आरपट को नै आसीबा so that ln हेगला माने log base e ओके यार वैल्यू टा एतिके हमें पाउछु राइट अच्छा so याको आउ टिके जदि हमें सॉल्व करिबा for the value of the Fermi energy level that is EF we'll find its value like this which is equation 3 and at absolute zero temperature माने at t equal to 0 Kelvin EF रो value हिजबो ई क्वांटिटी टा 0 हिजबो because एठी t अछि तमरो न्यूमरेटर रे so ED plus EC by 2 that means at 0 Kelvin the Fermi level lies exactly in the middle of the donor and bottom of the conduction band. With the increase of temperature, ଯେତେବେଳେ increase କରୁଛୁ T ର value greater than 0 ହେଉଛି, then the Fermi level drops and at room temperature it comes below the donor level. Okay, so putting the value of this EF जो Fermi level ର energy ଆମେ ପାଇଲା equation 3 ରୁ, ତାକୁ equation 1 ରେ ଯଦି ଆମେ put କରୁଛୁ ତାହେଲେ NE ର value accordingly ଆମେ ପାଇ ଯାଉଛୁ. ओके, एठी ED माइनस EC को आम नहीं जाऊँ डेल्टा E, राइट. सो देख ये फिगर रे आम देखा पाचु जो कनसेंट्रेशन बा इलेक्ट्रॉन्स पर यूनिट वॉल्यूम. ओके, तीन टा एठी एग्जांपल दिया है, गोटे ND1, ND2, ND3. ओके, सो ये डॉटेड लाइन टा डोनर लेवल देखौछि, एटा होछि कंडक्शन बैंड को. ओके, सो ये जो डेल्टा E जमती कहूली, it is equal to ED minus EC, and it is called as the ionization energy of donor impurity. Okay, now conclusion re ame kon kahiba, we conclude that the density of electrons in the conduction band is proportional to the square root of donor concentration. Then conductivity of intrinsic semiconductor is less than n-type or p-type semiconductor. Tapare there is a limit on the operating temperature of semiconductor materials. Then similarly the carrier concentration of whole tropy concentration ame bahar kari pariba in the valence band of p-type semiconductor, which is NH equal to this much. Okay, एठी n alpha जो गोटे देखुछ नुआ quantity, this is actually the number of acceptor, sorry n alpha तो नो, एटा Na. Okay, Na A for acceptor, so number of acceptor atoms per unit volume, and here the Fermi level lies exactly midway between the top of the valence band and acceptor level. Okay, and with the increase of temperature it will shift upwards. Okay, so up to this I have taken the p-type and n-type semiconductor from one book. Now this also I have taken from another book. Okay, तुम याको भी पढ़ी पार, आ जोटा तुमको यूजफुल पॉइंट्स लगुची तुम दुईटा जाक बही को मिक्सअप करके तुमर नोट अकॉर्डिंगली प्रिपेयर करि पार. Okay, so this is all about the p-type and n-type semiconductor. Okay,
Thank you.